Okay, so we're graphing a rational function. Okay, but the first thing we got to do is we're going to factor it. Okay, always want to factor your numerator and denominator before you do anything else. Um, so we're going to look here in the numerator. Don't get freaked out by this. I think this is the easiest way to do this. There's only one way to multiply to 2x squared when we're factoring a quadratic, and that's 2x and x. Now look to the last number. Well, it's negative 1. Well, that means we got to have plus 1 times minus 1. Now you just need to pick which one goes where, right? So I could try this, right? And if I do this wrong, I know this one's wrong, so we'll go back in a second. But if you notice, I go ahead and I multiply it out in my head. 2x minus x, that would leave me with a plus x here. That's not what I want, right? I need a negative x here. So then I just switch that. And what I want really is plus 1 here and minus 1 here. Okay, so now I've factored the numerator. Now I'm going to factor the denominator. That one's a little easier. We have x minus 4 times x minus 1 because we got negative 4 times negative 1. It's going to add to negative 5 and multiply to positive 4. So now we have x minus 1 cancels out. So that means the whole is at x equals 1. All right, now we have to find the y value. So now the nice part about getting rid of the hole in the graph first is that we can use this, what remains of the function, to do the rest of the problem. Okay, so that's what we're going to work with now. So I'm going to input 1 for x because I need the y value of the hole in the graph so I can graph it. Okay, so that's going to be now 2 times 1 plus 1, and that is over 1 minus 4. Okay, that's going to be 3 over negative 3. Well, that's just negative 1. Okay, so the hole in the graph is at 1 comma negative 1. All right, so I'm going to go ahead and I'm going to put that point here. So I'm going to have an open circle right there. I don't know what's happening in the rest yet, but I know I have that. Okay, let's do the x and y intercepts first, or next. So when I get the x-intercepts, I just need to put the numerator equal to 0. Okay, so 2x plus 1 equals 0. So that means 2x equals negative 1, and x equals negative 1/2. All right, so that means my x-intercept now is going to be, I'm just going to record it right here, is going to be negative 1/2, 0. All right, so I'm going to keep that info here. And actually, I'm going to go ahead and put that point right on the graph. That's negative 1/2, 0. So there's my x-intercept. Y-intercept. Okay, for the y-intercept, we need to make x equals 0 and solve and see what we get. So we input 0 for x. Okay, so f of 0 is going to leave us with 2 times 0 plus 1 over negative 4 is negative 1 over 4. Okay, 1 over negative 4, same thing. Okay, so that's my y-intercept. So my y-intercept, the 0 comes first, and that's going to be negative 1/4. All right, so notice that's like just below this. Okay, so we know we're going to have some curve like this. All right, now with the last two things we need is we need our VA and our HA. So to get the vertical asymptote, here's what you're going to do. You're just going to set the denominator equal to 0. Well, that one's really easy. X minus 4 equals 0, so x equals 4. Okay, so I'm going to go ahead and I'm going to put a vertical asymptote at x equals 4. Notice I'm going to kind of color code these to kind of help you out with this. Oh, let's do this. So that's going to be x equals 4. All right, so that's my VA. Now the HA, you remember, is just the coefficients that go with the largest exponent. So in this case, if you look back in the original function or the factored form, 2x squared over x squared or 2x over x means that just simplifies to 2 over 1. So our HA is y equals 2. So now I'm going to go ahead and I'm going to put that there at y equals 2. Okay, so now I have my HA, let's put it in the right color. I have my HA at y equals 2, and I have my VA at x equals 4. Now notice, remember, we know that these have to have a specific curve, especially this type. And so if I look here, I know it's going to have this shape. Okay, now if you were worried about what it was, you could actually input some numbers to see. You could input -2 here, and you would get 2 times -2 plus 1 is going to give me -3 over -6, which is actually positive 1/2. Okay, so if I input -2 into the function, that would actually give me another point that I could use. So that's positive 1/2. Okay, and you could do some more of that if you wanted. But once you get to right here, you really have enough to draw the curve. Let's see if we can draw that a little better. So we're just going to go through those intercepts here. And then we go through the hole in the graph, and then it goes down like this. Okay, you want the graph to kind of hug up against the asymptotes. Okay, now I know that if this is going down here, then it's going to have to alternate like this. Okay, now I have all my info and I'm done. The one last thing we're going to do is if we wanted to write domain. The domain is just any breaks in the x values. Well, there's only 2 points where that happens. That's the hole in the graph at 1 and the x value of 4 where we have a VA. So we're going to put our domain as -∞ to 1, then 1 to 4. So this is showing me that all these values exist until there's a break at 1, and then there's another break at 4 for the vertical asymptote. And now I have all my information here. I've got my function graphed. You could be really good about it and label it f of x, but now you are done.